Cool, we're recording. So one thing about the book came out around Python 3.2, 3.6, somewhere around there. Right now we're on 3.10. There's a couple changes in the past quite a few years. One is with Pickle. So we're going to talk about Pickle. What it is? It's serialized. It's a serialized object. So it's an object with other parts of it that are serialized. We'll get into exactly what it is in a second. But right here, this is important. It's deemed insecure, and you should only unpickle data that you trust. In other words, if someone sends you a pickled file, it's difficult to scan with antivirus. Often they don't understand those types of files, so you have to unpickle it or deserialize it. And at that point, sometimes there can be arbitrary code or malicious code involved in a pickle. So I'm not saying pickle is deprecated. There's ways to leverage it by using HMAC and some other things. JSON is the common way to go now. A lot of data formats have flipped over to just go, you know what, we'll just use JSON. It's serialized, it's structured, it's quick. A lot of people understand it. You don't need to understand the concept of pickling or unpickling. JSON's pretty straightforward. But it is still used in some legacy applications and things around the planet. But what it does for you is, well, we'll go through what it does. But what it does for you, it keeps track of objects, and it has already serialized so that you can reference them later. The Marshall cannot be used to, we'll talk about what the Marshall is and everything. It's not guaranteed portable across Python versions. So if somebody pickled something with Python like 2.7 and you try to open it up now in 3.12 or 3.11 or 3.10 even, it may not work. Serialization didn't go so well between Python 2 and 3 right here. Let's see. JSON, the comparisons with JSON, of course, data stream format of what Pickle actually uses. I'm not going to say it's deprecated, but it's getting there. You know, I'd almost say it's deprecated. It has methods like dump and dumps and loads and things like that. Pickle errors. We'll go through all that. But the concept of a pickler or even a database in Python, because you could have the DB module run in memory, we'll cover that too. A pickle is just like that. It's a jar. You put a bunch of stuff in it. You put the lid on. You ship it someplace, right? And then you open the jar. You dump it out. You use it, right? Just think of it that way. It's not necessarily a zip file. It's not necessarily a pickle jar, but in essence, it's a way of containing data inside an object and keeping track of it, obfuscating it, making it a little teenier, and then being able to ship it from place to place so you can transport data kind of effectively. Um, it helped out a lot when our networks weren't so good. You know, when gig to the desktop wasn't a norm, sometimes you had to pickle large files or pickle large data sets and then send them back and forth. But now that mostly everybody has gig to a desktop, it really doesn't matter. Does that kind of make sense? Or pickle strictly Python? To the best of my knowledge, yes. Yes. As a matter of fact, there's the only time I've ever ran across a pickle module or a pickle data file was using the Python language. I think it was made strictly to use with the Python like 2.2.2, I think, or if I remember correctly. But let's get into it. You won't see them often. Most people don't cover them or don't go into too much data or detail about them. We'll start off easy. We'll throw this here. We'll get rid of this guy. Now leave that one there. Get rid of this one. Put that right here. What's this? Let's see, is there anything else that I missed? Probably. Let me go. Is that it? Oh, okay. Get rid of that. Cool. So here, you import pickle. It's a module. Or as a matter of fact, I'm going to open up a shell first, so we'll run it from. We'll import it initially and do a dir on it to see what's in there, like we usually do. I gotta spell it right. Import pickle, dir on pickle. Now, it has all this fun stuff. Let's see. Compile pickle, dump dumps, extension cache, load loads, IO input partial read. This is like a regex thing. System unpack. A lot of these are very specific to the pickle module, and the context of them, you have to read the documents in order to really understand what this stuff does. The book just glances over it. I just glance over it. It's like I said, JSON is more preferred than this, but we'll check it out. Right. So I'm just going to do this from here since we already simple list 1, 2, 3, and now you'll see that when I dump it, it's all hex. So the way that it pickled it, it grabbed the data, which is a simple list 1, 2, and 3, understood it as machine. Well, it took it down to hexadecimal machine code because it's actually smaller. You see this little tiny B? That's a byte array. So it changed our data to a byte array, which in essence is closer to machine code, which is smaller because there's no spaces, there's nothing to interpolate. That's a new word. So, so now when you move this data around, when you do a type on T, well, T is not going to be the difference because it's, well, we'll do it. Type. You see it's a list because it's a list, but once you pickle it and dump it, it turns into this wild thing. Now, can we do NT equals pickle? We'll dump it instead of loads. Dumps T. And now we do type on NT. You'll see it's a byte array. It's bytes. So in essence, it takes up less space just because it's filling every byte in a row instead of taking data that has spaces in it. If this had spaces in it, and flattens it all down and goes, here's a byte array. And that just replay the array. So you can do a lot of cool stuff with byte arrays. Kind of out of scope. It's like more intermediate stuff on how passing data and traveling around between programs. Not very many things communicate via byte arrays. That's kind of like where Web 3.0 came in with the JSON files. So JSON is actually, we're going to talk about that next week, our last class together. I'm going to show you some JSON stuff. Not on the exam, not on the final, just good to know. Right. But Pickle transforms your data to a byte array. Right. I have a more in detailed version here that I believe is in your book as well. I already did that. Let's do this section right here. One, two, three. We take this one off right here, I think. Nope, I'll take this one off. So now in this example, we're going to go ahead and create a shopping list. We're going to create a file called a shopping list data. Well, what is that? That's just a variable, right? So let's go and check our location here. Let me pull this over. So let me get rid of that. File called. Oh, these names, these are awesome. So here you're going to see that I don't have a file called a shopping list data here, right? We're going to go ahead and create it. We're going to open it. We're going to notice that we're going to open it or create the file with write bytes. And then we're going to dump the shopping list to our file and then close the file. That's all this is going to do. So let's save this. Oh no, what happened? I do. Oh, there's more stuff. That's all. Oh man, I didn't know it was this long. This one needs to go. Okay. Save. So we're going to import pickle. We have our list, apple, mango, carrot. We have our variable, it's a file name. We're going to open that file name in write bytes mode. We're going to pickle dump our list to that file and then close the file. That's all we're going to do. And we're going to see that file be created right here. It ran, let's see. Boop, 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 boop. And here we go with our A shopping list data. It's 1 kilobit, right? I'm going to go ahead and open it. And it'll be like, hey, what do you want to open with? I'll say, I just open up a notepad. And you see that the data is kind of there, except it has these special characters around it. See, the thing with pickling is it necessarily doesn't obfuscate all your data. So if you were to put like sensitive data, healthcare data, PII, classified data, a password, a username, and a pickle, it may not be the best way to do it, right? Because it's still readable, even after you pickle it. And well, while it's pickled, it might be a byte array, but when you dump it, it's still in plain text, right? So we've done that. And now let's read this stuff, right? Let's read it. Let's go get rid of this stuff right here. So now we're going to open shopping list file. Do I have that? Or do I mean the one above it? Shopping list file. So we're going to go ahead and open that file. We're going to open it in read bytes. And then we're going to load the pickle into another variable. And then we're going to print out that variable. So in essence, we're opening up this 1 kilobyte file. We're loading it from the pickle format into a variable, and then we're going to display it, right? An error would happen. Shoplist file is not defined. So what I do here, shoplist file, shoplist file. Let me just copy that and put this down here for now. Oh, what's happened here? Pickle load, pickle's not defined. So now you see, even when I close the file and I imported pickle, now pickle isn't there. So now I have to re-import pickle, right? Now you see, kind of weird, right? Because I didn't close the shell, but I closed the file that used pickle, but it also removed the module, which is kind of odd, right? Usually the module stay there until you close the shell. So here we imported pickle, we redefined our file, we opened the file in read bytes mode, we loaded that file from pickle load, so load bytes, load the pickle, stores the unpickled data into stored list, we print the stored list, we get our list back, which is apple, mango, carrot from the original. Using these small data sets really doesn't show you the power of pickle. Right now, that file's 1 kilobyte. If you stuffed a bunch of stuff in there that was like, I don't know, maybe like 6 meg, and then pickled it, it might go down to 2.5 meg. So it's almost like a compression ratio, right? It's kind of not needed anymore, though, because of our excellent networks that we have now of high speeds, right? Just keep that in mind. So that's how you create a pickle. That's how you open a pickle and read it. You create a pickle with dump. You dump whatever object you want into, in this case, a file. And you open that file just the same way we have, and you load the data using load. Not that difficult, right? Now we have dumps and dump. We'll talk about this in a second, right? And then loads. And I'm going to let this rip from here. So this one, we're going to import pickle, create a list, 1, 2, 3. We're going to dump that T1 into S. We're going to call it S. We're going to see what happens here. So let it rip. Nothing, right? We never printed anything. Nothing. Like what's going on here? T1 is T2. We didn't get any true falses. We didn't get an S. Nothing, right? What if I print S? Okay, so now there's our bytes, right? We dumped T1 into S and we printed it. Now we have a byte array. Makes sense. My bad. What did I do there? Print T2. Now we reloaded it. We reloaded S into T2, printed it. Now it's our list back. Okay, so dumps and loads and dump and load. We'll read about what's the difference is here. And now this right here, how come I didn't get anything? Let me call in T1 over here. Knows what it is. Knows what it is. That becomes a true. T1 is equal to T2. Now T1 it's a direct comparison to T2. And we get a false. They're two separate objects. And when you call on the ID of T1, it's loaded in that memory space. And when you call on the ID of T2, you can see that the memory spaces are different, and that's why they're not is. The value of T1 is equal to the value of T2, but they're not the same object. Okay, good to know, right? How does this benefit us? Like I said, Pickle is almost a legacy technology that allows you to, we'll just run through this whole thing, that allows you to pickle data, or in other words, turn it to a byte array, make it smaller, compact, take it from A to B, or move it from A to B, and then load that data up somewhere else. Sort of obfuscates it. It's not 100% safe. JSON took the place, or slowly, well, it really did take the place of this. JSON really did take the place of this. But you're still going to run into it out in the wild because there's a couple things out there. So here we have a list. Now, a .dat is just a data file. I'm going to go ahead and delete this. We're going to go ahead and create it from scratch. We got 3 lists. I'm going to open this file in write byte mode, so it's going to create it. Then I'm going to dump each list to that file. Then I'm going to close the file. We created 3 lists of data. We created a file in write byte mode, opened it. We're going to dump our lists individually to that file, and then close it. Then, when it's done, we're going to open that file. We're going to load each, and then print each, right? That's all. Just a proof of concept, full top to bottom. There we go. And here's our prints down here. So it worked full concept top to bottom. Now, instead of pickle loads fin, instead of these, we're going to do this again. And I'm going to use loads instead of load. So a list, delete that. Oh, can't delete it. Why? Because we never closed it. I opened it here, never closed it, right? That's FN close, right? Cool. Now I can go ahead and delete that file. We're good to go. So now we're going to try pickled for. We're not going to print any of these lists. And now we're just going to print the list 4, see what happens, see the difference. So here we go. Byte-like object is required, not an input-output buffer. So let's look at our problem here. So we wrote our data, close the file, open the file. Let's take a look if that file exists. It's 1 kilobit, it's good to go. We pickled list 4 equals pickled loads fin. What does this mean by load the file in? What's in this file? Well, it should be our lists, right? Well, it is, but they're kind of in this weird obfuscated nonsense that they're there, but not in plain text, right? So Let's get away with all of these and see what happens. Trash this file again. Ah! Never made it, right? Because it errored out. So it never closed the file. And you're going to run into troubles with this if you use this stuff and have to have a bunch of little tabs open and close things and destroy files, create files. It's part of the game, right? So now here we go again. A byte-size object is required, not an input-output buffer. So this right here, when you open the file in RB mode, it's an input-output buffer and loads fails. When you want to load objects from a pickle, it behooves you to know how many objects were in there. Well, instead of using dump each individual object, we could have used dumps and then called out all our objects and dumped it into one object in the pickle, and then we could use loads to load it all back. Well, let's read that and make sure that's correct, right? Where is that? It's down here, right? So dumps, object, okay, so is dump, protocol none, protocol done, star, whatever that means, fix imports true, bulk callback none, return the pickled representation of the object as bytes. Okay, that's good. Instead of writing it to a file. All right. Now, instead of writing it to a file, write the pickled representation of the object to an open file object. So dump writes to a file, dumps writes to an object other than a file. Well, what does that mean? Well, a memory object, any object really, right? A variable, right? But then after you dumps that, you have to load or loads it. Well, load represents the object from an open file object. Loads returns any type of object that must be a bytes-light object. So when you're using a file, you use dump and load. When you're using something other than a file, you use loads and dumps. That's it. But that's about it for Pickle, honestly. There's a lot more to it. Honestly, I've never had to use more than those four that we went over, the four methods: dump, load, loads, and dumps. Those. In production, I think I've used these 4 times in 10 years. Usually it was like XML or JSON. So that's all the time I'm going to spend on this. So it's good to know what they are, because you may go on an interview and someone may say, "Hey, okay, I see you have Python. Do you know what pickling is? Because we use it here." Some places do use it. I'll be honest, but just know what they are. Notice that C, PYC, right? It's a type of object, type of file type, and know that basically it's not quite a compression. It's more of a way to put data in a format and move it from A to B. They use a stream format. I wouldn't call it a perfect stream though, but take it for what it is. Sort of cool, right? I know there's going to be probably some questions on this, but that's fine. We'll have fun and discuss them. Now, this is a module. I don't even think they talk about it anymore, the DB module, because so many people use SQLite. SQL, for those of you who don't pronounce SQL. Interface to Unix databases, DBM. So I know in the book also it covers the database module, which we'll review as well. But it's one of those ways to move around a lot of data in a byte array from A to B if it's necessary. It may not always be necessary. The database module, on the other hand, import DBM, it's a more of a Unixy type database module. And this doesn't appear to be much on the surface, right? Error, IO, NDB, new database module, open, OS structure, sys, which DBs, things like that. Now, you can do a help on each of these individual ones, but we're going to go ahead and do some of these. But the cool thing is, it's a lot like a dictionary. So remember how you define a key in a dictionary and then have it equal and then give it the value? So here we're defining an object in the database, a key value pair. This is all a predecessor to JSON. All right, keep that in mind. I keep saying JSON. Anybody know what JSON means?
Script object notation.
Bingo. That's it. So that's a fancy way of saying, let's see, capture one. We'll get rid of this. That's a fancy way of saying, so JSON developed this file format. It's basically a dictionary of dictionaries. Your key can have other keys, and that key can have multiple keys, and those keys can all have different values. So it's a hierarchy approach. Think of a vehicle. Make, model, color can all be a type from a manufacturer or make, right? Make, model, color could be under the make. I'll pull up a couple examples of JSON notation here in a minute, but it's widely used. A lot of databases you could run queries against SQL, Mongo, and Hadoop, and dump out JSON files, and then query them quickly or make graphics out of them because it's a key value pair. It's a little cleaner at times, right? You could dump all the keys, dump all the values, dump both. It'll make sense when you get out in the real world. You start using these objects. You'll be like, okay, I'm getting familiar with this object. The more you use it, you're like, okay, I understand what this object can do now. And then when you start to read about the object types, you start to go, okay, it's used in all these dynamic places. Son of a gun, I never knew, right? But this is a good intro. So we're going to import the module. We call on the database module .open. Opens a method, works just like open a file. We're going to give it a name. We're going to give it a C, which is for create. Now, if it doesn't already exist, it'll create it. Now, we don't have a captions over here. I deleted it, right? And then this database object only is going to exist in memory. And we're going to go ahead and call that object. We'll call on the database itself, give it a key with a value. And then here, I'm going to call on the key, and we'll see what comes out. We're going to run through this, right? Save it, F5, let it rip. Cool. So you notice we get these things as B's again. You notice this byte array, right? Let's see what it created for us. Well, it created a directory file, a DAT file, and a back file. Well, let's take a look at these. What's inside them? I'm going to open the dir file. So inside the directory file, it appears to be our keys, and the values are 0 through 12. Okay, whatever that means, right? And there's a test GIF. This is a test, 512 to 14. Wonder what that means. Let's open up the DAT file. Boop, boop. I don't like things always opening because it's a pain. So you notice in the DAT file, in the data file itself, we have a silly walk and clease. Does that make sense? Oh, look at way over. This is a test. So it's storing data in a byte array and placing it in very odd spaces, right, within this file, but it's in clear text. That's a problem, but we don't know what it goes to because the keys are in the directory file and the values appear to be in the dat file. Well, what's in the back file? The back file is a backup of the dir file. So this is important. If you destroy your dir file, often kept at a different location when you're dealing with databases, you could copy your back file from a secure location, change the BAK to a dir, and restore your database, or at least some operation. It creates a backup dir for you. Sort of nice. But all this is going on in memory and written to these 3 files, right? So what this does is creates the key of Cleese, photo John Cleese, calls on it, doesn't do anything because we didn't print it, calls on that same key, changes the value to a silly walk, which we saw in our captions.dat file. And then we define test GIF, and way at the back, 500 characters into our file, we found this is a test. Now, since it's a byte array that's in key value pairs, we treat it like a dictionary. And we say for each key in our database, print the key, followed by the database key, which will give you the value. And that's where we come up with this output right here. Now, it's a byte array. It's stored in plain text in a dir and dat file. I think for next semester, I'm going to do a real large representation of this because seeing this and only doing it for 2 objects is like, oh, okay, whatever. But when you have 1,000 or 10,000 objects and you create a database, it makes much more sense, right? Think of each of these objects or each of these keys being an account number. Now, not a username, just an account number. And then each value could be an address. So if you're given an account number, you could look up the address of the user. Helpful, right? You can couple this in a couple different ways. You can make it more interesting. But at the end of the day, it's key value pairs, much like a dictionary. And you can organize it, save it in a file automatically by using a DBM. So no longer do you have to create a file, open the file, make sure you're writing it to the right thing. You could do it on the fly using the DBM open. It's a gateway drug. It's an entry level for work with local databases. DBM is still pretty popular on Linux and Unix machines. I can't name the company that does this. I can, but I'm not. I can't. There's a company that does a lot of things for EDR, endpoint discovery and remediation, detection and remediation. My bad. Kind of like an antivirus, except newer. When it queries your system, and saves all the data in a DBM format because it's smaller, and it could ship it to a machine on that subnet. And then that machine compiles all the DBMs into one DBM and then sends that one DBM from all the machines on that subnet to the master node somewhere on the network. It's called distributed computing. Like I said, now we have gig to desktop. You no longer have one command node talking to everything all in your network. Your one command node could pick a winner or a command and control, kind of like a command node in each subnet, and say, I knight you to do duties for me, collect everything you know about these people on your subnet and report back to me. So now you just have a subnet calling back to one machine. And then say if you have 15 different subnets, you don't have 15 times 2, 55 machines talking back to one master node, writing back and forth to a database. You have 250 nodes writing to one database, and then you have 15 of those, and now those 15 send data back to the master node, and the master node only processes 15 files instead of 15 times 250. Does that make sense? That's distributed computing. It's dipping your toe in it, right? But does that make sense to the class? What I just stated there, how that operates? Got a yes from Logan. I like it. In other words, why ask 2,000 machines all this data and then saturate your network with responses back? Ask 15 nodes to ask who they know, and then collect data on who they know, and then those 15 nodes give you the data back. 15 connections over the WAN. Every other local area network sends to one of those 15 nodes, well, the master node, the one node on their network. So you're saturating layer 2, which should be fast because you're all in the same network within 300 feet of each other, because you're on a switch. If you're wired, if you're wireless, you could be still 300 to 1,200 feet, but that's still faster than going all over the planet and sending all the data around the planet. Isn't that cool? Do you guys ever even think of like software doing that? A huge way that networks leverage this as another way is for updates. Like if there's a subnet, say if there's a campus network, you work for a company that has a campus. There's 17 different buildings. In each building, there's multiple subnets, right? They're all essentially managed on the same domain. They all pull updates from one update server, or do they? I come into the office 6 a.m., open my laptop, plug it in, back to the domain. It says hello to the domain. The domain goes, hey, we got updates ready for your system. Shoots the updates to my system. My system gets updated. Everybody else comes in the office between 7 and noon. They jump on, log in, they connect. The domain says you need updates, but get them from Zach's machine. Instead of traversing the entire network, he already has the updates you need. Just grab them from his machine. So instead of saturating the entire WAN with constant data calls of updates and networking, you could isolate it via subnet. That way your network is optimized and the delivery of updates is faster because it's not saying yes, hello, going through firewalls and routers and switches. It's coming right from my machine right to yours. It's a trusted agent for delivery. Distributed computing. A lot of things work like that, believe it or not. That's why a lot of power went down to the desktop too. As networks got better, local networks got better, gig to desktop and so on, a lot of things got pushed off in the enterprise to endpoints or distributed computing. Isn't that fun? Learn a little bit about cool architecture stuff. But that's the end of the day, man, of database and Pickle. Pretty rare. I'd have to say seeing a DBM is more common than seeing a Pickle nowadays. But in walks JSON, right? What's imports of JSON? So JSON is a default module in Python for quite some time now. I don't remember when they put it in there. But if you do a dir on JSON, you're going to see that a lot of things looks the same. Dump, dumps, load, loads, codecs, scanner, detect encoding, all this stuff. So let's take a look at JSON, right? I've done this before, I think, in this course, briefly show what a JSON file is. But let's get a good, let's do a example JSON file. We'll go right to here to see what this one is. So this is the book example, right? Glossary, title, subtitle, glossary list, glossary entry, the ID, sort as, glossary term, acronym, abbreviation, stuff like that. So it's this main glossary with multiple titles and things of it. Okay, that's sort of cool, but kind of a sloppy one. Let's check out this one. Here's an example. This is a very simple JSON format, which looks a lot like a list or a dictionary, doesn't it? Key value, key value, key value. There we go. JSON, key, quiz, subkey, sport, subkey, Q1, question, options, right answer. This may be cool to potentially put into a dictionary for a trivia game or multiple lists using the index on how to deliver a trivia game, right? So I'm trying to guide you here for your final, right? Objects of objects. This was called sport. This was called maths, right? And here they have two questions under maths. Here's the question. Here are the options. Here's the answer. So you can code this, call on maths Q1 question, Q1.question. It'll present this. Maths Q1 options will present the options. The user can type in the options into user input, and then you can compare user input to maths Q1 answer, which would be 12. That's how that data could be used. Not bad, right? Pretty cool. But the structure is very much a dictionary of dictionaries. No big deal, right? You could read it, you can get through it. It's fun stuff. So any questions on those two technologies and all three kind of to covering JSON? I know we're not really going to dive into JSON, but so quiet. So what I really want you to focus on this lesson is opening and closing of files. Did I go over with in this class? I think I did, right? Did I?
Yes, you did.
Cool. Use with. Like when you're working with files, use with, you get that free close, feels like a function. It's the way to go. It's just a little cleaner, in my opinion. Let's see what we're going to do here now. This group lab, it's the same lab from lesson 6. The default integers, all this fun stuff. And instead of bring them out to the screen, which we still do, we create a file in write mode. And then for every integer in my range, the random one, we write it out to a file. And then we close the file. And then we open up random integers. Then we use it to display everything. Well, we throw it in memory, my file, we just go through there, right? And then we append it. Not too bad. Let's make sure it's gone. Where is this at? Lesson 7. Lesson 7, let me see. Boop. That's going to make a file called random integers. It already created it. Let's destroy that. I'm going to run it. Let's go 44 numbers, hit enter. There's our random 44 integers. We have everything we need. Do you want to try again? We'll say no. Thank you. End of. But now we save those random integers to a file. And now we have our complete 44 saved to a file. So now we could regenerate the outcome from our one-time play if needed. Not bad, sort of cool. Sort of like logging, except this is saving output, right? So in essence, if you wanted to record or save how people were using one of your files, since you already have variables of all the input that you asked them, nothing's stopping you from writing these to a file to see how they used your script, often called a log, right? Not necessarily an error log, but in this case, it would be like a usage log, right? Now, programs can get very technical. You can save users' interactions in a usage log. You could save all tracebacks and errors as an error log. You could write your own custom errors and save them in an log file, a log file. Now, this is outside the scope of class. This is more sides the high-end intermediate. But there is import logging. So I don't think you have to do this all by yourself, right? People already wrote some cool stuff. So last resort, root, threading, time, traceback, warnings. You could write your own warning logs. You could write your own traceback log system. You could record all those in files. This becomes very handy when your script bridges that gap from doing one thing really well into doing multiple things, like becoming a real live, like multiple headed program. And then you can start to capture all your logs from all your different pieces into a confined area or logging formats. Way out of scope of this class. What we're doing right now is just one clean file, having a blast, getting one thing done really well, then moving on. But moving on in your Python experience, I want you to understand that logging does exist, so you do not have to reinvent it. And spending a couple hours learning this module is better than printing everything to a screen or writing it out to a file. Just leverage logging and have it grab the tracebacks and everything for you. It's worth learning. That's my point, right? I hope that makes sense. I'll probably make a video just of this module, and it'll probably be an hour and a half long. But this is definitely not in this class. But if you keep going with Python, you're going to want to use it, especially if your scripts get pretty hardcore, right? Now, I know we covered try, except all the fun stuff. But that's kind of it. You know, I just wanted to cover Pickle databases, tell you about how JSON kind of has been invented since the book is written, and kind of it didn't take the place of Pickle and database or database module, but it sort of did. Just wide adoption of the JSON file format kind of blew it out of the water. Now, you notice that like when you work with a Pickle or work with a database module, it's like working with a dictionary, key value pairs. Same thing with JSON, right? So the knowledge of working with a dictionary goes far beyond that of just working with a dictionary. You could work with other object types and file types. That's important. As you progress using Python and you start to get weird data sets back, dictionaries, JSON files of dictionaries of tuples or this or that, or some weird files, break them down to objects you know how to handle. Change a complex object to simple things, often a list or a string, because you all know how to use for loops and you all know how to do string comparisons. So use those. In is one of your best friends. In you could use with a lot of different types of data within Python, and it's a quick Boolean, true or false, right? So just remember the simple things, right? It'll pay dividends. But yeah, let's take a look at this group activity here. And don't worry, if you're here, you're gonna get credit. Let me take a screenshot of who's here real quick. With the snippy. I can't type today. What can I though? Honestly, you guys see me type. It's horrible, right? Cool, we're good.
What did you mean by if we're here, we get credit?
I mean, you can participate in the group activity, but since we're here and we already discussed it, that's kind of participation to me. This was kind of a 6-liner. to last week's, it's really not a full-on group activity. It's more of an addition to lesson 6, if you ask me. Right? Because all we're doing is this right here, which is 1, 2, 3, 4, 5, 6, maybe 9 lines of code, if that. Some of these aren't even needed. This one's not needed. You could have left it open. Didn't need this. You could probably just do that and dump this out and be done with it. We were just fancy here. Opened it, wrote to it, closed it, reopened it in read mode just to append it, add a line, and then close it again. But there's 1,000 different ways to do this. This is just one way to output data to a file. Still have your script run natively, but then, it also saves the data for a later time, which is pretty darn handy for most things, right? Saving data. What I say way in the earlier class, there's only 2 types of IT folks, right? People who create data and use data, and people who allow people to get to data. That's about it. Yeah, cybersecurity is kind of in there somewhere, but you're usually using data and collecting data too. So, and data is the new gold. And just be aware that collecting a ton of data at once, a ton of data. What's a ton of data? Well, anything over 300 meg, right? Anything over 300 meg of raw data is still considered pretty large to move over some networks, right? 300 meg at a time. Like, I don't know. I'm curious. Where would you guys draw the line of copying a file on like a network or even over the internet? Where do you guys draw the line? What do you think?
When it says 12 hours to download and then I cancel the download because I don't want to download it anymore.
Yeah, and certain technologies replace that, like BitTorrenting, where you get a section of the file from 10,000 different locations, distributed computing, and you pull it back to your host, and then your host puts that file back together into little chunks, right? From little chunks to one big file, right? That's how torrenting works. Anybody ever used any type of torrenting platform? No? Oh God, I'm old. That's all that told me. Zach, you're old. Okay, cool. Thanks, Olivia. Thank you. Thank you very much. Yeah, there we go. We got it. Eli. Thanks. Thank you. Thank you very much. So, torrenting is still alive and well. When you need to move a lot of data very quickly in a distributed format, it works very well. I'm not going to say Bitcoin uses that type of technology, but it does use a sort of distributed computing for hashing, right? So not really the same. But these things, it'll all come down to file size, transfer speeds, and where you're at. And sometimes you'll be like, man, this file's huge. And then you'll be like, hold on, can I make it smaller? Well, does Python have an archive or zip utility? Has anybody checked? Zip isn't there. What do you think it is? Archive? What do you think? Is there Python zipping or compressing? Anybody know? Let's go to Google. Data compressing and archiving. Creation of a zip, zlib compression, LZ llama compress. There seems to be quite a few of them, right? Let's take a look. Oh man, zip file objects, zip file. Yep, BZ2, gzip, zlib. So you start to see tar file. Tars are pretty common in Unix and Linux. Right, zip files are almost interchangeable, but not really. Gzip, also called gunzip. Back in the day, I think it was named after the gentleman who designed it. So there are ways to compress files, right? Zip file. Here you go, Eli. What does that buy you? Well, compression, right? We're not going to talk about how compression works, but squeezes it, gets to somewhere, inflates it. Deflate, inflate, right? And the different compression mechanisms out there, you can spend a lifetime learning them all. But there's a couple standard ones. Cool stuff though, right? So whenever you have large data to move from A to B, your choices are to compress the file, right? Or cut it up into smaller files and then send it on its way. You could do that with read lines, read. You could say read for my range of lines, read every 200 lines and write it out to another file, and then create file 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then send each of those off on its way and then rebuild them all on the other side. Open file 1 through 10, save as file. I see where I'm going now. So you could do this at a very low level if you needed to, but chances are there's a module that could do it better for you, right? Anybody thinking about going to the hardcore networking, like a network engineer style? Anybody? Okay, because PCAP files, packet captures on a network could get large pretty quick, especially if you're sniffing traffic on a very heavy saturated link, and you're being greedy and you're sniffing everything. That file could get big quick. Oftentimes you have to cut those files up to transmit it, or open it up and filter it with T-Shark, or I guess Wireshark if you like GUIs. But you leverage Scapy or T-Shark and chop it up into separate files and then send it on its way. Wireshark does have a packet cutting utility or packet. It's basically chopped up into small, what's it called? Extract packet or exit packet or something packet. And it's an little unknown, well, it's known, but not very many people use it. It's an executable that comes built in to Wireshark where you can cut up large files. Let's see if I can find it on my machine. Isn't this stuff fun? Let me see if I was Wireshark, where'd I put it? What's it called? What is it called? I'm looking right at it. Edit cap. Yep, right there. So when you install Wireshark, you get this small little joker right here called Edit Cap, and you can use it via command line to create smaller PCAPs from a large PCAP. So that'll help you out too if you ever need to chop something up, which happens pretty often. Probably 3 times a week where I work. Like I have to chop up different file types at least 3 times a week. So just keep that in mind, right? But let's see. Anybody have any questions about the material covered tonight? Pickle, DBM, and then just a bunch of fun extra stuff that's really not tested upon, but cool. Well, I'll talk a little bit about the individual lab then. So, World Series. Open the text file. This is important. If you download this text file, and if you change it or alter it in any way, you need to turn it in along with your script, because I'm not going to have it. I'm not going to have the changes you made to your file. You can do this exercise without doing any changes. Some of you will open this file, alter it, run your code, send me your code. I'll run your code and it'll fail because I don't have your text file. When you go to turn this in, if you alter the text file, turn in your text file. Okay, I've said it. There we go. I'm going to have to put in the announcements too, right? Which I will. But this is pretty standard. Prompt the user, give them some direction. walk them through the lab. By now, you know to use like functions and everything and prep yourself up. I'm really not worried about it. A lot of people didn't get it done. And I sort of gave like a grace period because of the holiday. And to be honest, most people didn't get it done. And by most, I mean like 90%. But yeah, good job, Olivia. They were due last Sunday, but hey, did you find it difficult? Did you crush it? Yeah, there's still a lot out there. That's why I'm not going over it tonight either, because it'll be like a free for all, right? Orange, potato. I get it. I found this lab. Not too bad, but didn't tackle pickling. Yeah, you don't need to leverage the pickle or the database in here. I mean, if you did the database thing, I'd rather have you use the JSON, honestly, because then you could do like a team is the key, and JSON allows you to have multiple values. So you can put every year behind the team. And then when you call on the team, you'll get a list of the years back. And then to get how many times they won, you could do a length of the key, which would give you the value, the number of the values. JSON's a lot easier to work with. I'm going to touch on it next week a little bit just to show everybody that, yes, dictionaries are awesome. They're out there. You will see them. You will see JSON as well. And knowing how to leverage JSON is a bit more important, I think. Nowadays, it's two, 3 years later. Here it is. It's important, right? But that's how it is. But yeah, just have fun with this. If you already did it, awesome. Logan, hit me.
Yeah. The lab, I could not get it to work by just running the file. I had to create a dictionary
Mm-hmm.
and then manipulate the dictionary to output everything because I could not do it solely off of the file. I'm sure there's a way. I just couldn't figure it out.
You'd have to read each individual line. For line in lines, read line and then in. Does that make sense? Each line one by one. Yeah. You could loop through each line. Read lines would read the entire thing, and then you'd have to be like still traverse every line to find what you're looking for. And then if you found the team, you'd have to grab the next line to get the year. So there's ways. It's built this way to see how you critically think to solve it. Which method you chose. And to be honest, there's multiple methods to solve this that are covered up till now. Which one you chose to solve it's up to you, honestly. And I grade equally if you do use read lines, create a dictionary, it's all the same. But there are more Pythonic ways than others. But this is at the end of the day, reading in a file and generating a file is a finite core concept of anything. And just be aware of that. Like, this is the main takeaway from this lesson is, can I open a file? Can I generate a file? Because that's what you're going to do out in the real world. You're going to gather data from somewhere and put it into something for someone else or some other machine to use. And to do it exponentially, like this is awesome. I was thinking the other lab, 7 wasn't terrible, just struggled getting accepted only specific words to find the file. And only those words. Olivia, you always propose such unique things to your solutions. Yeah. I'll show you a couple different ways. Let's see if I have a fun one here. Usually I try to do it before class a different way. I always like to test myself. Here's one. Let's see. Let me open it. Lesson 7. What a fun lesson. Let's see which one this is. Okay, this is kind of cool. Whoa, I wrote this a long time ago. Let's take a look at this. Holy cow, we're going way back here to Time Machine. Let's take a look at this. So I wrote a function called open file, and guess what that does? It opens the file. Try accept, prints running variable equals false, else last winner list. For line and fin, so I fin it, it opens default read mode. So then for each line, if line not a new space, var list winner append line lower strip. So now I'm writing something, list winner list. Okay, so I'm writing the values to a list. That close it. I return the value, return to var running. Let's see what we got down here. Get user input. Hi, welcome to blah blah blah. Enter your stuff. Check input. So now I grab the user and the list. For each item in my list, if item equals var input, var, okay, then var list count +1. Okay, so I'm getting the count here. Then I capitalize, I display the list, display results. For each item in my list, print the item, exit the program. So here's my main program. It calls it on my functions. Let's see if this will really work. Did I have that file in here? World Series winners may or may not be the correct World Series winners. Let's see. Enter full name. Let's see how this goes. Let's do a New York Yankees. Not my favorite team, but I like to pick on them because they won 22 times, I think, in this data. Do you wish to continue? No. So here, I didn't do the full count, but could I have? I could totally add a counter to this. But it generated a list, pulled from the list, rock and roll, right? Not too bad. So if I hit close here, right, and I should have some of these objects still in memory. Oh, nope, it's not defined. So I close it, it's gone. I think the lab we're supposed to use a counter. Yep. In this case, I showed you the years. And if this is I could output these to our list and just do length as a list. And then that's the count of years. So I necessarily don't have to do a counter. I could just do the length of how many times they won. Same thing, right? Well, I mean, this is just one example. It's not the example or even a good example, you know? A lot of times when I do the things in the class, it's not perfect because I don't want to give it all away, right? And that's the only one I really have on this machine. I'm going to do it again here. But the key is understand how to read in data from a file, manipulate it, and then generate something else. That's it, right? And this isn't even all that perfect now that I look at it. Like I would change a couple things, but just an idea. No, it's not too bad. I'll grade them. We'll have fun, right? So the weeks to follow. Let's talk about that really quick. All your grades will be updated. The next week that we meet, it's going to be a discussion over any topics that you have a question on that we covered in class. Once that's out of the way, we'll talk about the final exam and the final lab, which will be available tonight. Then from the final labs and the final exam, we'll go into bonus material or like fun stuff to do with Python. And, that'll last for the rest of the duration of the class. And that's it. I'll set you free. You'll be all grown up. There's nothing I could do, right? But all the videos will always be up there. I usually do them for every class, and I'm going to group them up on YouTube. I'm going to put them in a channel with the dates so everyone could be familiar with like what class or what thing they've done. I don't like using the same videos every class. Now, I know inside your class there's videos that are reusable, but that makes sense, right? Edit mode is off. What's this mean? Okay, it's on. That's just for me. But be honest too. Like during the course surveys that you get, let us know. And I'm just not speaking for my class, but all the classes. Let us know what you think about the courses and how they're laid out, so we could fix them. Alter them, make them better for future generations. I get some decent feedback, and I try to alter my class every semester. Cool. I guess I'm going to stop the recording.